Alright guys, so I know we were a little bit rushed at the end of class on Thursday so that we could do the exit ticket, so I just wanted to go through a couple examples and the notes on Learning Target 4 a little bit more. So now we're solving rational equations algebraically, so a big difference here is that we're dealing with equations rather than expressions. So the rules are a little bit different of what we can do. So here are the steps. The first one is to multiply all terms by the LCD. Now, this really just means multiply the numerator, right? Because if we're multiplying by the LCD, right, we're technically multiplying all of these, fractions by the LCD over 1. So for equations, the LCD is only going into the numerator, okay? Now, before you can multiply by the LCD, you have to have one, okay? And you might need to factor to find it, okay? It's important, though, that you use the least common denominator because of what the next step is. So the next step is cancel what can cancel, right? We should technically clear the denominators here. Clear the fractions. There should be no fractions left if you did step 1 properly, okay? And then once there's no fractions, you're going to solve, and it's either going to be linear or quadratic. It'll always be linear or quadratic. If you don't multiply by the LCD, though, if you just multiply by a common denominator, not necessarily the least, you could end up with something cubic or quartic or bigger that you have to solve. So to be able to solve it, we have to focus on the least common denominator. Okay, and then last but not least, you always have to check your answers in the original, just checking out for the fact that we can't divide by 0. So when we plug back in, we've got to make sure that we don't get 0 in the denominator. Okay, so it's 3 steps. We just have to make sure we keep it clear between when we're simplifying expressions and solving equations. Now, I did show you a method in class on Thursday for solving that used the simplifying method. You can do it that way as well. But I'm going to stick with this because it's 3 pretty easy, straightforward steps. And it's important to understand the difference between an equation and an expression. So for this first example, we've got 1 over x equals 6 over 5x plus 1. I just made that 1 over 1, so everything is a fraction. So to find our LCD, I'm going to start with the first fraction and put x in it. And then when I move to the second fraction, well, if you see, I've already accounted for the x. I just need to add the 5. And then, we never really have to account for 1. So our LCD here is 5x. So now I'm going to multiply each term by the LCD. So 5x, 5x, and 5x. And then I'm going to see what's going to cancel. So we'll have 5x over x equals 6 times 5x over 5x. And I would not multiply anything together until you've cleared the denominators. Because if we were to turn this into 30x, we would have to then turn it into 6 times 5x to simplify it. So just leave it like this for now, because as we will see, x over x cancels, 5 divided by 5 cancels, and x divided by x cancels. So this equation becomes 5 equals 6 plus 5x. Okay, now this is a really straightforward linear equation, right? We just need to isolate x. Subtract 6, divide by 5, x equals negative 1/5. And then noticing when we kind of plug it back in, we get in the denominator negative 1/5. That's supposed to be an equal sign. In the denominator, negative 1/5, negative 1, and 1. So this is good. It doesn't make us divide by 0. So our answer is negative 1/5. And you can see, yay, we did that one correctly. So this is the one we did at the end of class on Thursday, but I figured we could do it again. Maybe a rewatch would help. If you have it in your notes, maybe you kind of follow along with your notes to see if this makes some more sense to you. So the first thing we need to do is pick out the LCD. So again, we have a 1, so I'm just going to put it over 1 so that I can see that it's a fraction. And when I'm picking out the LCD, I always start with the first fraction. okay, and just write down the denominator because that has to be part of it, right? Remember, a least common denominator is talking about factors of it. So like, a plus 3 factored is really a plus 3 times 1, and a plus 2 factored is really a plus 2 times 1. So notice, the only factor they have in common is 1, and everything has a factor of 1 in common. So since they don't have anything in common, the LCD is just going to be them multiplied together, right? But on this last example, they did have something in common, right? The factors of x are x and 1. The factors of 5x, we've got 5x. Oh, that's supposed to be 1. 5x and 1. Well, they already have an x in common, so we only put one x in the LCD, and then we had to put the 5 as well. So that's one way you can think about LCDs if you're struggling with the idea. So this is our LCD for this problem, a plus 3 times a plus 2. So I'm going to have to go through and multiply each term by that. So remember, we're multiplying numerators only, so I'm going to multiply the numerator by a plus 3 times a plus 2. Didn't really fit that well. A plus 3 times a plus 2. A plus 3 times a plus 2, right? Because remember, the point of this is not to combine fractions like we were in Learning Target 3 and simplify them that way. We don't have to do that. What we're trying to do here is kind of clear the denominators, get rid of the fractions to make it a little bit easier on ourselves. So notice in the first fraction, a plus 3 divided by a plus 3 leaves us with just a plus 2 times a minus 2. And then here, nothing cancels, so we just have a plus 3 times a plus 2. And then in this one, we have a plus 2 divided by a plus 2, which cancels. So we're left with 3 times a plus 3. Okay, now this has become an Algebra 2 problem. Not necessarily an easy Algebra 2 problem, but we just need to multiply, combine like terms, and solve. So I'm going to multiply each of my little terms together right now. So a times a is a squared, a times negative 2 is negative 2a, a times 2 is 2a, a times 2 is negative 4. Then here, I'm going to put brackets to show I'm subtracting this whole term, right? This whole thing was being subtracted. So I'm going to put this in brackets to showcase that. A times a is a squared, a times 2 is 2a, a times 3 is 3a, and 3 times 3 is 6. Then 3 times a is 3a, 3 times 3 is 9. Let's simplify by combining some like terms. So that is nice, right? Negative 2a plus 2a goes away. And then I'm going to distribute this negative in. So let me change those signs. So this becomes minus a squared minus 2a minus 3a minus 6. Right, I was just distributing that subtraction in to show I'm subtracting all of this. So then a squared minus a squared cancels, and we are left with negative 4 minus 6 is negative 10. Negative 2a minus 3a, I did a very bad job circling that, but negative 2a minus 3a becomes minus 5a. Equals 3a plus 9. So for a second this looked like it was going to be a quadratic, but turns out it's just linear. So we need to get our a's on one side and then get our numbers on the other. So we have 8a equals negative 19. Divide by negative 8 is what I need to divide by. Positive 8, my bad. And we get that a equals negative 19 over 8. Okay, then we have to check in our denominator, so we just need to make sure that, when I put a in for here and here, I don't end up dividing by 0. Well, negative 19 over 18 plus 3, that's not 0. Negative 19 over 8 plus 2, that's not 0. So we know that our answer is good. Alright, let's try one more example, and I can also do more this weekend. If you have one that's giving you particular trouble on the homework, send me an email about it and I'll try and do one similar. But for this one, we're going to start it like we always start them. finding the LCD. But for this one, I don't have factors in all my other ones. So let's factor this first, because remember, the way we find the LCD is by looking what factors they have in common and what they don't. So I'm looking for something that multiplies to a positive 15 and adds to a negative 8, and very conveniently, that is negative 3 and negative 5. So I can find my LCD now. Well, if I look, I can see that, we've got an x minus 3 here, an x minus 5 in the second fraction, and then I don't need to multiply by x minus 3 and x minus 5 again because they're already accounted for. So here's my LCD. So now I can go ahead and go through and multiply each numerator by my LCD, right? Because again, I'm multiplying really by x minus 3 times x minus 5 over 1. So it's only going into the numerator because we're going to see what cancels. So we don't actually need to make them have a common denominator because we're not necessarily trying to add and subtract them here. If we wanted it to have a common denominator, then yeah, we would multiply this by x minus 5 over x minus 5. But then we'd have to multiply through by the LCD at the end anyway. So this is just a quicker way to do it. So now when I look at each term, well, I can see x minus 3 divided by x minus 3 cancels, x minus 5 divided by x minus 5 cancels, and then here we have x minus 3 over x minus 3 and x minus 5 over x minus 5. So that leaves me with 2x and x minus 5, 2x times x minus 5. Here I've got 2x and x minus 3, and then just 3x. So let's multiply those through. This becomes 2x squared minus 10x plus 2x minus 6 equals 3x. Well, you should notice right away this is a quadratic. And to solve a quadratic, factoring by whatever method, it's got to be equal to 0 first. So I'm going to subtract 3x from both sides and combine like terms. So that will give me negative 10x plus 2x is negative 8x minus 3x is going to be negative 11x. So we have 2x squared minus 11x minus 6 equals 0. Now we need to factor that. Okay, so if we were to factor it by grouping, we'd be looking for what multiplies to negative 12 and adds to negative 11. I'm just going to have it factored here in like kind of a guess and check way because it's not too hard. I need something that multiplies to negative 6. So I have some options. I can put like 3, 2, 6, or 1 and adds to 11. So I need this to be a 6 and this to be a 1, this to be negative and this to be positive. Again, you can use whatever factoring method you would like, so long as you know how to factor. And we can't forget it's equal to 0. So then we set each of our factors equal to 0, 2x plus 1 equals 0, x minus 6 equals 0. Solve gives us x equals negative 1/2 and x equals 6. And then we just have to check to make sure that nowhere we get 0 in the denominator of our original. So if we look back, we would have, negative 1/2 minus 3, negative 1/2 minus 5, and then, whatever those end up being, negative 3.5, negative 5.5. None of that's going to give us 0, so that one is good. Then if we were to plug in 6, we would get 3, 1, 3 times 1, and that's not going to be negative, or that's not going to be 0 either. So we are good. So we know that both of these answers work, and that's done. Again, this is just an introduction. We're going to cover this more in class on Tuesday. We're not moving on to a new learning target until Wednesday or Thursday. However, if you want to see more examples on EduCreations this email, just this weekend, just send me an email and I can do that for you guys. Okay, hope this helped.